It's so busy now the time, but yeah, I appreciate you like spending some time with me today. And then I mean, because some of you I haven't met before, so I'd like to have a brief introduction about myself. So my name is Diep, and I received my PhD in Educational Management Studies and Research from the University of South Florida. And I love teaching, and I have opportunity to teach and co-teach statistics and measurement courses for about 8 semesters. I also have experience like doing consultancy for the college education faculty and graduate students. And I also like join research team and also collaborated with interdisciplinary researcher to conduct studies. So that's some brief information about me. And that would be my main part today. And this the topic of my teaching presentation today is about intro to independent means t-test. And because it's an undergraduate course, it shows about statistics, but because I do not know the students, I would like to make some assumption for my students. So I would think that the student already has some basic math from like a math class, like math 141 or math like 166 or equivalent as student in senior or junior level, and they may be like different in terms of their comfort level with statistics, like maybe student from our department, maybe they are more comfort. That's assumption. And also, I also assume like students come from different programs across college education and human development. So now it's the plan for our lesson today. So today we will go through some recap from last class because I want to also refresh something we have learned last week and also to make some connection with what we are going to learn this week. So the second part I will go for the new topic, which is the independent means t-test. And also I would like to walk you through the steps to calculate the t-statistic. And it's going to be fun part. We have some activities about that, and also the last part would be like how to make conclusion based on the result of the independent means t-test. So that's the plan. So first, let's do some recap. So last time we talked about the research hypothesis and the null hypothesis, and I hope you still have something like recall something. So let's do some example like. For example, look at I will have some hypothesis, and then you would determine if like work with your neighbor and then discuss if this is hypothesis, research hypothesis, or it's gonna be statistical null hypothesis. So in the real class, I will let students maybe to discuss with their neighbors to talk about first one for example some students may think the innovative teaching method is more effective than the traditional teaching method, and they may think, oh, this is gonna be research hypothesis, and then yeah, they got it right. And then the second, you have a scenario, the hypothesis, maybe the level of anxiety for boys is the same as for the girls at elementary school, and it is the new hypothesis. I hope they got it right too. So, and then the third one is could be like another research scenario where the researcher makes interested in examining if doing pilots, like people from in sport management, or like if like doing pilates exercise is more effective than doing yoga in improving functional movement, and what do they think if that the research hypothesis or is a statistical null hypothesis? And then next step, and in summary of the recap, then we often like as a researcher, if you do research, you often come with your research hypothesis. But then when you want to test the hypothesis, then we need to set up the null, to translate the research hypothesis into the null hypothesis, right? And then, for example, as a passionate educators, you always try to improve, to have new teaching method to improve. You hope you will have to make the kids learn better in math, right? And then the research hypothesis, my treatment, you hope like improve the kids' math achievement. And then in this case, what is the null hypothesis? The null hypothesis is the null, right? And then, the null hypothesis means the treatment has no effect, right? So that's what we have learned last week. And then this with the new test. So whenever you do research, we always do any statistical test, then we often have question. When do you want to use these tests? Why we use this? when we can use that, right? Especially after you add the new statistical tool to your toolbox, you always ask that. And the independent means t-test, sometimes they can call the uncorrected means t-test or t-test for the uncorrected groups. Then this test when we use to compare the means of two independent groups. Here is only two independent groups. If you want to compare more than two groups, we will learn about that in the following classes. And then in this scenario, you will need to determine that the dependent variable it should be continuous. For example, in our previous example, it would be math scores. And or sometimes you can see in the when you encounter in the in the practice, you can see sometimes even the some like Likert type scale, for example, you have more than 5 categories, then the variable also considered as continuous, right? And then in this case, the independent variable here is binary, which includes two different type of groups that we want to compare. And those are when and the next part we have some example, and then I would like to the class to think about your area, which example you can think of when we can use the independent means t-test. Maybe let me go first. Lady first, right? And then first, well, as in earlier we mentioned, we may be interested in examining the effectiveness of new teaching methods using an iPad or teaching method for 6th graders versus the traditional method. Or in another scenario, you may want to investigate the differences in attitude between researchers in the rural and urban areas. Or if I say maybe in special education, you may be interested in compare the stress level between boys and girls in IB programs. And do you have any example you can think of in your area, like when you can use the independent means t-test that will compare the two groups? I hope like some students will have some like scenarios of like exposure, like they would think of in the real scenario like what they can do, and then we can go through that. And then now is the first activity for the class, because before we go to further in the t-test, I would like to walk you through some like example how we apply the independent means t-test, how to calculate the t-statistic based on the real an example. So the research in scenario in these activities, we will have in this scenario, a researcher is interested in like the researcher developed a new teaching method using an iPad app to teach math, and he or she was wondering if the new method is more effective or if different in terms of effectiveness to the traditional teaching method, just like giving the lectures. So at the beginning of the semester, the researcher, like they call it this, 10 students were randomly assigned in two groups. 5 students were assigned to the we call control group, which is a traditional teaching method, and then 5 other students were assigned to the experimental group, which is the group using iPad app. And please be noted, like for easy calculation, for illustration purpose in the class, we just have 10 participants. But in the real with the practice, you should have much more larger students, right? So it's just example like to have easy calculation for the class. And at the end of the semester, the teachers administer a math test, and then record the score from these 10 students. So before you do any analysis, I recommend you to go through these questions to screen the data, and then to ask what is your research question, to determine what is your dependent variable, what is your independent variable, and is it continuous or categorical, so to make sure like that the t-test is used appropriately, because as we mentioned earlier, right, we need the dependent variables to be continuous, and then the independent variable will be the binary, which is two groups, right? So now please work with our neighbors, and then we will go through. I will spend like around 5-10 minutes to go through this, and then talk about what is in the example we gave before. What is the research question? What is dependent variable? And also, I also would strongly recommend you to also look at their data. The data in this example just have 10 students, which is manageable, small. But in the practice, when you collect data, I would recommend you to look at the data to see if any unreasonable unusual things, because sometimes you may have typo, or sometimes as a teacher, you know the student, you have to give to student why this test he or she doing so poorly. You will check the test and see, oh, what's going on, right? And then, so that I think that's the habits that I would like to encourage you to do, like to screen the data, to know the data, what tells you know the data, and also even the also like to recommend you to check the assumption of the test, which like we should do when we do statistical tests, and then we will go through this next class. But I just would like to mention for you this one of the steps we would do before we do any further with to analyze our data that we collected. So in the real class, I would maybe give students 5-10 minutes to work on this, and then we'll go through with each research. So from the last part, and then now we will discuss, okay, so what is the research question from the previous, like the scenario, right? So like now, is the research question would be, is any different, is the technique a teaching method for secretors between the traditional and the innovative method. And also the dependent variable here is a secret of the math score we collected, right? And the independent variable would be the teaching method with two values, is the traditional or the innovative teaching. And we will screen the data and make the assumptions. And then next step is like the connection with what we have learned last week. Now we need to set up the null hypothesis. Now you're all clear, like with the null hypothesis. Now, like when we have the mean of the two groups are equal, or in another word, the difference between the mean is equal to 0, right? So we have say null hypothesis, because we need to set up the null hypothesis and we test the null hypothesis, and we also make conclusion about this null hypothesis at the end. So you know if your method is effective or not. Then this data the researcher collected, and then we have math score from 10 students, 5 students from each group, and then this lady. And then next part, it will be the fun part. We will have some small calculation, I hope. And the reason I would like to give you there's a hand calculation and go through this to calculate the t-statistic, even though I would also encourage you to use the statistical software like a SAS, SPSS, or Stata. But in this class, I would like to walk it through this step to see, like in the t-statistic, we calculate what are the elements in this, component in this, and how it impacts that. And you have some sense and insights of the t-test, why we use it, and how we make conclusion about that. So the step we need to, so you can see from this t-statistic, we need to calculate the difference between the two group means, right? We need to calculate the whole estimate of the variance here, and then we get the square of this, and we have the standard deviation, and we have group size for each group that we get that from the data, and then the degree of freedom would be the total sample size minus 2. So that's all step, and even though the formula may look a little bit scary here, but like when we go through the step, we see like each step, and you will see it's easy. Then in this, I will have like the handout for, and then please work in group. I mean, you could choose 2 or 3 and then work on this. Maybe, I don't know, if you're busy, but it's a real class. I will ask a student to do this and then do some practice with that. And then after maybe 10 minutes, we will review the results. And then for the first activities, I will go through, and then, yeah, that's what I give them. So there's the first group and the second group. That's easy to see. And then in this, like for these activities, I think the first thing you would do, maybe now you have the score for each group, right? The student math score. First step you would do is calculate the mean of the first group, and then you could have the deviation from between the mean and each observation. So deviation from this observation, you have the value here. You get square of this, and then we're gonna have a sum of square of the deviation. Then we have the first component, like for the full estimate of the variance. Let's do the same with the second part. So if you do step by step, like you know how to calculate the mean, right? From last class, earlier this semester. And then we just square it and then get sum of it. Then we're done with the first part, almost the major part. So, like, yeah, I think I mentioned earlier, like, the reason I use hand calculation. And then this is the result we got. So I believe you will all get it right. So we have calculated everything, the deviation, the sum of square, and then we plug in the formula for the pool estimate of the variance, and we will have the pool estimate of variance for this sample is 2.5. We get square root of this, we have the standard deviation of 1.58. And then we will use it to plug in our t-statistic formula, the final step. Then now we look at, again, this is a formula for the t-statistic. We have the group mean, we know the group mean of the first group was 7, the second group was 8, and then we know the square, the deviation, the pool is 1.58, and we have group size 1 and 2. So you can see from this formula, if the difference between the two groups is big, then T is going to be big, right? Or like if the variance is small, then also T gets big. So if you want to increase the T, such as you need to see this difference would be big or small. And also we have the group size for each group here. So now we have the statistic, we have the degree of freedom here, which is we have group size. First group was 5, second was 5, so we have 8 degree freedoms. So now the next step would be we have the t-value here, the obtained t-value here, and then we look, as you remember last time, we look at the direction, the t-distribution, the direction red area. Then now we will look at that because we need to find the critical t-value, right? So now in the t-distribution table, so you please use these 3 pieces of information to look at the p. So we would need the alpha level, which commonly used 0.05, and the degree of freedom here we have, remember we have 8. And in this case, with the test would be two-tail. I mean, because if the null hypothesis is like the difference between the 2 teaching methods, so it's two-tail. But if like and it's commonly used, it's a two-tail test. Because if you have one-tail test, like if you have strong belief, like you have evidence, have theory before, like that, the new teaching method would be more effective. Then you can use a one-tail, but more commonly used the two-tail is more used or commonly used. Then there is the student t-distribution table. Then you can look at this, and with this is a degree freedom column, and then in our sample we have 8 degree freedom, right? And then look at this. So here we have 2-tail alpha, 1-tail. This is confidence level. We just look at this with 2-tail alpha level 0.05, and then look at this 0.05 here, and then this 8 here. Then the critical t-value for 8 degree of freedom and the alpha level 0.05 is around 2.31. So we need to use that value to compare with our obtained t-value we had before to make the decision. So look at this. So remember last time we had 2 areas. This, if we need our t-value, obtained t-value, if it's fall within this white area, big white area, so we are going to fail to reject the null hypothesis. Right? So in other words, in that case, we say, oh, then we will not accept it and fail to reject, and then we will conclude like there's no evidence of the difference. If your critical t-value, it's an obtained t-value falls within this red area, because it's 2 tails, so and then the t-distribution is symmetric. So this is alpha level with our alpha 0.05, right? And then if we divide it by 2, then this 1 tail, this another tail. And if our obtained t-value falls within these 2 red part, then we will fail to reject. And then our teaching method is more. We have feel like the difference between the teaching method and the traditional one, right? So remember our obtained t-value we calculated earlier. So yes, it's negative 1 should be someplace here. So what should be our conclusion about this? Are you to? Yes, So that's what we just done. So our decision is fail to reject the null hypothesis, and we do not have the evidence. We need to collect more data to see if the teaching method is more effective or not in comparison with the old methods. Then and then I will give the student another activity. And in this case, I will not calculate for them. In this case, I calculate. And then in this case, I will let the student do like a calculation and then make a decision based on the critical t-value and the obtained t-value. And then they will determine like if like it's an exercise for them to like I know like we know that in if they do research, then they some exposure with what they need to do like with the t-test and where to use it. And then that is the activity 2, and then the data for activity 2, and then using this data we test a null hypothesis. It's also 2 new like a method in the writing. Like I was working in a peer review like a program, the writing Department of English, and they were installing they got the called peer review, and they were interested in examining if like additional peer review is good and is more helpful in teach student writing skills than just a traditional method that's only review from the teachers. So that was like some of the part of the research, and the data is part from that. Then that is done for our class today, and then for next class we will talk about the assumption for the independent means t-test, and also we also talk about effect size, which like also from parameter. If the size we may collect the data, but we are not sure like if the size of the maybe it's statistical significant, but how big it is, how small it is. We will talk about that next class. And do you have any questions so far?
So how do you interpret the result? Like what does it mean when you have what does the
result? So like I think in the previous activity, so here it is a decision, and then we fail to reject, and then we interpret as there's no evidence that the teaching method is different from the traditional teaching method in teaching math for 6th graders. So that's the way they if they use the statistical softwares, then we can but for undergraduate class I don't know how much exposure here, but I thought like maybe we were, because we for undergraduates intro to statistics, we just want to introduce for them so they are aware of what statistical analysis or test available that could be applied to them. But if they want to do the using the statistical software, they can learn more, and then we can provide like the code, and then also how to interpret the result of the code. So it depends. I don't know if the situation, if like here, if like a student are encouraged to do that, I can add that part to this. But because like I don't know, I assume they are like different level, different I don't know, like the level of them to using statistical software, and then if it take a lot of time for them just to use, I think maybe it's not worth it to make the effort. So yes.
How did you get the number 2.306?
Oh, that's from the table. This one. So we have that is critical t-value in this sample size. And we have the degree of freedom of 8, and then we have alpha level 0.05. It's a very good question.
So in your like class or plan, when will you teach the confidence interval?
That's a very good question. I think we would introduce that before this class. It should be like so close to when we talk about hypothesis testing.
Okay.
And then I think we can talk about confidence interval and like central limit theorem, something like that. So I think we could go with that.
I have a question. In the last slide, you said you are going to teach the assumptions
Yes.
after this class. So
Yes.
why did you prefer to teach assumptions after like teaching independent sample test? Why it's not in the beginning?
Yes, very good question.
And you also kind of like mentioned kind of like assumptions like the dependent variable should be like continuous or some kind of, So
that's a very good question. I was thinking a lot about that too, and then I was something, but I think because for this one class I don't want to put everything in one class. I just want first to aware that we need to do that, but because for assumption we are a lot of things to talk about that. So I was afraid we put together a lot, then so maybe like overwhelmed or like maybe like confused, like if what can I do, and then with assumption, and if they do assumption and interpret the assumption, because assumption is big deal a lot, and then it's not only for the independent means t-test, also for regression and other paths, right? So I think we need to do it like closely, and maybe in one class for that. Yeah. But if it's 2-hour class, I can incorporate like this. Yeah.
Class for us.
Yeah. For this, I assume it's just like 45 minutes class or so.
And we just like assume that you already taught the independent variable, dependent variable, the types of those.
Exactly.
Yeah.
Exactly.
Yeah.
Yes. Yes. Yeah. Thank you.
It can go back to the sample. You have the two group of people, right?
Yes.
Yeah, I can go back to that slide.
You mean this one?
No, the failed early one.
This one?
No. One more.
Oh, with the
Yeah,
image of the
yeah,
people.
Yeah. Why you do these two different shapes? That's any.
Very good question. I was trying to mimic INM. Like this is like, so it's not so like, yeah, just yeah.
Oh yeah, now
I see it.
That's funny. I just want to like
That's
just
funny.
feel like maybe because I feel like because I was yeah, I'm trying to make it fun because I was reading a book about teaching, and then people say like if you make something fun at the beginning, still feel more interesting to go next. So even though I was not successful in that.
I understand you put that two different colors, but they have different.
Yeah, I mean the two different
funny.
colors
There's
also
some
was
reason
my
why.
purpose. Because I want to differentiate the two groups, and then when we do the calculation, they know that, okay, this calculation is for the first group, and the green calculation is for another group. So
And I just like realized another question. So do you plan to mention anything why you pick like same sample sizes, or do you plan to like
that's a really
say
good
something
question.
about like the sample
Yes,
differences?
yes.
It's
I mean,
just like for I know like simple 5-5, but yeah, do you plan to mention anything about sample size in like this maybe
yes,
slide?
I do. I mean, and not in that, but in the assumption part, because
Yeah.
because it's really important when you
Yeah.
design the class. Because we did a simulation study about the independent means t-test, and then we found that the equals group size is really important.
Mhm.
So that's why I choose the equal, and also like in the assumption like for the test class, I will talk about that, like I will emphasize the importance of the equal sample size.
Why equal sample size is very important.
Yeah, it's a good question, because like in the simulation study we did, like we try different factors, like for example the different level of normality, variance, and we found that for the t-test, when we have equal sample size, even though we have a non-normal data, and then the t-test would perform very well in terms of type on error and statistical power. So that's why we thought, okay, except only like severe non-normal, so like I think. So that's what we did. And also like when we collect the data, it's difficult to know the population variance, right? But if we know the equal sample size, then you will feel more confidence, like the t-test is gonna work well.
Because the F-test is robust for the heterogeneity,
Exactly.
the violation of the heterogeneity,
Variance.
violation of the homogeneity assumption. If you have the balanced sample size, the equation actually you can look at the equation, divide it actually.
Right.
Once you have the balanced sample size, the variance actually you will
Yeah.
just get out from the equation.
Right. That's
So the balanced sample size is important.
It's really important. Yeah. So, yes.
Can you talk a little bit about your approach to assessment?
Oh, that's great. Yeah. You mean the assessment here is very broad. So
Assessment of student learning.
student learning. Okay.
Mm.
Because I was teaching like measurement for teacher, and it also assessment of student learning, so classroom assessment, right? So, I think it's really important, because I think I keep talking about this a lot today, but like I feel like if you have a great teaching, then it's equally important. How do you know? How do you measure? How do you know if it's great? If you do not like measure student learning outcome, right? So the classroom assessment, like you will measure the student outcome, and then you will know like which part of teaching is perform well, and then how to improve that based on the classroom assessment. Especially, and so when I was teaching measure for teacher like classroom assessment. We have different type of assessments, but our goal is to make sure like the assessment we measure, we assess what we have taught and what we intend to measure. It's not something else. It's not like you are teaching math and then you measure like something like what they learn in science, right? So you want to measure what's relevant, what you really want to in that area. So I think that's a really important part. And also like the teacher, if they when they know the student how their students perform, they also can improve their learning like from based on every. I mean, so that's why I also recommend my pre-service teacher like you do classroom assessment and then you look at your data, then to know like what you have done good. So look, for example, you have tests and then look at the question and say why this question is easy but many students couldn't get it. So if like you measure it to the question and look at the question and also look at the student performance to see how you're doing. So I think it's very important.
But in terms of your actual class, how do you assess your students?
Oh, you mean like assess my student?
And imagine this, introductory undergraduate level.
Right.
What approach do you have for
Oh.
formative and summative feedback
Oh,
assessment?
okay, I understand. Yeah, thank you. I think from this, no, I think I in the class I would formative in terms of, for example, formative assessment. I would like to see from the class activities. That's why we have some class activities. Also, I would like to have some quiz, online quiz, and like so they can do like answer questions related to the class that they have learned. I will see like a sort of how they are doing and then provide feedback. So like and also I think I also want to have research project or something and provide feedback for what they have learned and then to see like how to improve their learning. I mean, if they what I have done and how to improve them. So that's my approach. Yes.
So if you teach this with the online
Mhm.
format, what are you gonna do? Something different, or are you gonna make it something different in terms of assessment, also in terms of content to distribute to students? How are you gonna do that?
Yes, I think of course because like for example the class activities, I cannot ask students to do it with me at the point. So I think I need to come up with an alternative like assessment like maybe it's maybe an assignment for them to do it by themselves and then turn in their work and then I will provide feedback for them for those assignments and then for these class activities and also I think maybe I will create them like a discussion board and then the student can like share their answer, then discuss why they answer, they pick this question and that question and why they, and other can comment why you choose that, why it's not, you didn't choose that, another one instead of this one, something like that. Yes.
Maybe for some students, the homogeneity of variance may be more abstract concept for them. How to explain more easier to understand?
Oh, that's a really good question. Yeah, I think maybe the variance I would think of maybe like we maybe talk about the difference, like a variance. If you talk about like if like for example, if you if you are teaching a regular classroom, you would expect more variance